Hello everyone, today we will learn about inverse matrix. Let's say we have two matrices which is matrix A and B. If we were to multiply both matrix A and B, we will get identity matrix. This shows that matrix A is an inverse to matrix B and matrix B is an inverse to matrix A. In conclusion, if multiplication of matrix A and matrix B produces an identity matrix I, then matrix B is the inverse of matrix A and vice versa.
How can we determine the inverse of a matrix? For example, determine which of the following matrix is the inverse of matrix A, 4, 1, 7, 2. As you can see, we have two options, 4, 1, negative 7, 2 and 2, negative 1, negative 7, 4. Now, we simply multiply matrix A with both options and the one that results to an identity matrix is the inverse of matrix A. Let's see the correct answer. The answer is matrix 2, negative 1, negative 7, 4. As you can see, the product of both matrices is identity matrix 1, 0, 0, 1. Thus, it is proven that matrix 2, negative 1, negative 7, 4 is the inverse of matrix A.
Now, on to finding the formula to calculate inverse matrix. First off, given matrix A equals to A, B, C, D, let's assume the inverse matrix of A is equal to PQRS. As we learned earlier, the multiplication of matrix A and inverse matrix A will result in identity matrix. So we will also input the formula here. So, ABCD times PQRS will equal to 1001. After that, we can expand the two matrices using matrices multiplication method and we will get this. From here, we can form four equations and we will label each of them from 1 to 4. Our next step is to express PQRS in terms of ABCD using the four equations above. First, we can use the third equation to express R as the subject. We can see that R equals to negative CP over D. We will make it our fifth formula. Substitute 5 into 1, so we can have P as the subject in terms of ABCD. Since there is a fraction, we will multiply the entire equation with D. Then, we can factorize P from the equation and bring AD minus BC to the right and we've got P. Next, sub P into 5 so we can get R as the subject in terms of ABCD. To express S, we can make Q as the subject from the sixth equation and substitute the sixth equation into the fourth. Multiply the equation with A to eliminate the fraction and factorize S to express S in terms of ABCD. Lastly, to express Q, we can substitute S into the sixth equation and expand to get Q in terms of ABCD. Now, since we've established earlier that we assume inverse matrix of A equals to PQRS, we substitute the expressions PQRS in terms of ABCD into the equation and simplify it. And now we have determined the formula to find inverse matrix.